Hello and welcome. In this video we are going to look at an example where we are going to apply Hess's law to find the enthalpy of reaction of this equation, formation of ethane, given the different enthalpies of combustion for hydrogen, ethane and carbon. So the first thing to do, we are going to write the equations for the combustion of these elements and this gas ethane. So for carbon, you know that carbon is a solid. It will burn in excess oxygen to form our carbon dioxide gas, and it will release 393 kilojoules per mole. So we also have hydrogen. It will burn in oxygen to form water in gaseous form probably, and the heat given off is this. So we have to balance this equation by putting here a half. We also have ethane, C2H4, which is our gas, presence of oxygen gas. It will form carbon dioxide plus our water, and the heat given off is minus 1393 kilojoules per mole. So we also need to balance this equation. We shall put here a 2 and a 3. So the first part is done. Now we need to try and arrange this last equation where we have our ethane to try and produce this ethane. All we have to do is to reverse this equation. So we are going to reverse this equation, and we shall have 2 molecules of carbon dioxide with 2 molecules of water. So these two will combine to form our ethane, C2H4, plus our 3 molecules of oxygen. 3 molecules of oxygen. But one thing to notice that now the sign will change. It will become endothermic, so it will become positive 1393 because it's a reverse reaction. So now what we are going to do, we are going to play around with these first two equations to ensure that we can manipulate them together with this third one and obtain this equation here. So how are we going to do that? As we can see, we need 2 water molecules, we need 2 carbon dioxide molecules. So we are going to multiply each of these by 2 so that we get 2 molecules of carbon dioxide and also 2 molecules of water. So starting with equation 1, that means we shall have 2 carbon atoms will react with 2 molecules of oxygen. I'm multiplying all throughout by 2 to form 2 molecules of carbon dioxide gas. But now our heat is also going to change, and it will be twice negative 393 because we are forming 2 molecules of carbon dioxide, kilojoules per mole. The same applies to this second one. We shall have 2 molecules of hydrogen gas reacting with a half times 2, which is 1 molecule of oxygen to form 2 molecules of water. Still now we shall multiply this by 2 as well. So here we shall have twice the energy lost, 286 kilojoules per mole. So now one thing we have to do, first try to check through and ensure that the equations are balanced. So actually all of them are balanced. Now we are going to try and see what actually happens. In our first equation we have 2 water molecules, and in the last equation we have 2 water molecules are under product. So actually these two kind of cancel out. because they're on both sides of these three different equations. When you look at 2 molecules of carbon dioxide, they will cancel out with these 2 molecules of carbon dioxide. Now we have 2 molecules of oxygen plus 1 molecule equals 3. This side we have 3 molecules of oxygen. So actually now this one will also cancel out. So if we are to add the 3 equations, we shall remain with 2 carbon atoms joining together with 2 hydrogen molecules to form ethene C2H4. So all we have to do is to add positive 1393 plus, now this one we have to multiply and multiply, then we add, and if you do that we shall get 35 kilojoules. Obviously positive 35 kilojoules per mole. So the enthalpy of the reaction is 35 kilojoules per mole. So we shall have to put the plus sign to show that actually the reaction is kind of endothermic. That's how we can use or apply Hess's law of summation, heat summation, to find the enthalpy of this reaction. Thanks for watching. Don't forget to subscribe or leave a comment. I'll try to follow through. Stay well.